We are discussing the in-text questions to do with alkanes. The first question is write the structures of different chain isomers corresponding to the molecular formula C6H14. We are also supposed to write their IUPAC names. So chain isomers implies that they vary in terms of chain length. So the first one is obviously going to be the open chain. So that's CH3, CH2, 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 1, 2, 3, 4, 5, and 6. So this is called as N-hexane. The next one, so what we are going to do is we are going to write the next isomer. So we are going to change the chain length from 6 carbon atoms to 5 carbon atoms. So that's going to be CH3, CH, CH3, CH2, CH2, and CH3. So 1, 2, 3, 4, 5. Second position, you have a methyl group. So 2-methyl pentane. Now, we can also have this methyl group at the third carbon atom, and that is what we are going to do next. So CH3, CH2, CH, CH2, CH3, and at the third position you're going to have a methyl group. So the name is going to be 3-methyl pentane. Okay, now what we can do is to the same substituted one, we can basically shift one of the carbon atoms. Or first of all, let's do this. Then we can also shift this from here to this. So the chain length shifts from 5 to 4. So CH3, CH, CH, CH3, CH3 and CH3. Basically, we've changed the 5 carbon atom chain, main chain, to a 4 carbon chain. So that's 2, 3 dimethyl butane. Now, this can be at the same carbon atom. So, we can shift it to this side or this side because from the nomenclature's point of view, irrespective of where you shift it to, you shift this to this will be carbon number 2. If you shift this to this will be carbon number 2. So, because of that, we're just doing it at random. So, here you have a tertiary carbon atom, quaternary carbon atom. And this is called as 2, 2 dimethyl butane. So these are the possible structures. So we got like 5 of them. These are the possible structures along with the IUPAC name for N-hexane. Let me just quickly erase this. The next question is write the structures of the different isomeric alkyl groups corresponding to the molecular formula C5H11. Now C5H11, and we are also supposed to write the IUPAC names of alcohols obtained by attachment of the OH group at different carbon atoms. Now there are 2 ways that we can do this. Let's first figure out the various ways the 5 carbon atom chain can be, arranged. So the first way is obviously going to be a straight chain. So 1, 2, 3, 4, 5. Okay. The next way is going to be, notice I'm not talking about the hydrogen atoms right now. So we can have an attachment over here. So from 5, our chain length is going to become 4. Right. And we can also shift from 4 to 3. So these are the 3 major ways by which we have the C5 arranged. Okay, now we need to figure out OH group. When OH group is coming into the picture, obviously one of the hydrogen atoms of the pentane has gotten replaced by the OH. That's why you have a C5H11, which is 5 2s are 10 plus 2 is 12, and we should, for an alkane it would be C5H12, but it's C5H11. So we are going to be figuring out the various ways the OH group can be attached. So in the first case, you have a straight chain arrangement. In your textbook it's given as a table and they've just arranged it, but I feel like this might be easier for you to understand maybe. So in this case you have a five membered chain, so open chain, so it can be attached to the last, or the first carbon atom rather. So 1 minute. So it can be attached to this carbon atom, so OH. So I'll just number this for our convenience. So the first carbon atom, so CH2, 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 CH2 and a CH3. So this is pentane 1 all, because at the first carbon atom. The second one is it could be at the second carbon atom. So the structure would be CH3, CH2, CH, OH, CH2, 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 1, 2, 3, 4, 5, yeah, 3, 4, 5, CH3. So since the OH has been attached to the second carbon atom, this is pentane 2 all. The third one is going to be at the third carbon atom. Look, it's our wish you could have numbered it backwards as well and written the structures. The names would have still been the same. And yeah, so this is just easier because for some reason I've always found numbering it from the left to right easier than right to left. So the third case is going to be at the third carbon atom. So CH3, CH2, CH, CH2, CH3. And here you have an OH, pentane 3 all. So these are for the open chain. Okay, next we'll be looking at this chain. Now over here you have 4 carbon atoms. Okay, now here our OH group can get attached to the first one, first and fourth. One second. Yeah, it can get attached to the first one, that is, this will be considered the first. It can also get attached to the third carbon atom, and it can also be attached to the So it can get attached to any of these carbon atoms, the first, second, third and fourth. So that way we get 4 different structures with 4 different names. And remember, this is just for our understanding. When it comes to the fourth and the third, there will be a slight change in their names. So let's look at the first case where we attach the OH to the first carbon atom. So OH, CH2, CH, CH3, 1, 2, 3 and 4, CH2, CH3. Okay, so you have the OH getting attached over here, right? So the name of this one would be, since OH gets more priority, it'll get the least number. So 1, 2, 3 and 4. So 2-methyl butan 1 all. The next one is where it gets attached to the second carbon atom. So CH3, CH, there'll be no OH. OH, CH3, right? CH2, CH3. Okay, now here, obviously 1, 2, 3 and 4 does not make sense. So 1, 2, 3, 4. So at the second position, you have both the methyl as well as the alcoholic group. So 2-methyl butan 2 all. Okay, the next one is going to be it attached to this one. That is a third carbon atom according to our, our understanding that that's the third carbon. According to us, it's not, I'm not talking about the IUPAC name, basically. We're just numbering it for our sake. So CH3, CH, CH3, CHOH, CH3. Pause over here, try and write the name on your own. So here in this case, if you number it from this side, 1, 2, 3, and 4, the carbon attached to the OH gets 3, but when you number it from right to left, it gets number 2, and because of that, the right to left number is preferred, and that's why I kept stressing on this being our numbering of the compound. So you have a methyl group at the third position, so the name would be 3-methyl butan 2-ol. And the last one is going to be attached to the fourth carbon atom. So CH3, CH3, CH2, CH2OH. So this obviously is going to get first priority. So you have 3-methyl butan 1-ol. Now notice 2-methyl butan 1-ol and 3-methyl butan 1-ol are different from each other. That's why we had to write the OH group attached to each and every carbon in the main chain. And we're not talking about carbon atom OH group getting attached over here, because if it did, okay, let me just show that as well. So let's take, for example, fine, you're like, okay, makes sense. Let's just attach, since this carbon atom is there, we might as well attach the OH group to this carbon atom. So let's see what happens. So the structure is going to be CH3CH, CH2OH, okay, and CH2CH3. So it's going to be butan hydroxybutane, right? That's the name. No, that's because when we consider the longest chain, we'll be taking this carbon into consideration because it has a functional group attached to it. And so this would basically mean 2-methyl butan 1-ol, which is basically what we have over here. So because of that, we will not be considering attachment of the OH group to this carbon atom because it gives us the same structure as this one. The next one is this particular arrangement of carbon chain. Now, first of all, this carbon atom cannot form any new bonds, so it's only going to be these 4. And because these 4 are basically the same methyl group, okay, because of that, irrespective of where you put the OH group, the name is going to stay the same, right? So because of that, you have CH3, CH2OH, CH3, and a CH3 over here. Okay, when we consider the name, we'll be taking 2,2 dimethyl propan 1-ol. Now you can think, okay, let's just shift this OH to let's shift it to this carbon atom, and when we do that, I'm just doing this for you to understand it better, baby. CH2OH, and you have another CH3. So in this case, you can consider this as your main chain, and at the second carbon atom, you have 2 methyl groups attached to it. Again, the third case, let's take it again. CH3, CH3, and here you have a CH2OH, and you could take this as your main chain or this as your main chain. Any of them can be taken as your main chain, and even then you'd be getting the same name of the compound. And if it was attached to this one, again you would have had it as the opposite of this. So with that, we're done with answering this question. So what I did was, what they asked us was to draw the different isomeric alkyl groups corresponding to the molecular formula C5H11. So that's what we did over here. However, you could fill in the hydrogen atoms to denote that an OH can get attached at that particular position in each of these cases. And then what we did was, we basically attached the OH group at various positions in this chain. And with that, we're done with this question. Next video, we will be continuing with the in-text questions.